Thank you for joining me for my Tech Talk. My name is Anthony Anderson. I'm the Director of Marketing and Business Development with Precision Combustion, Inc., or PCI. I'll be talking about our frangible coatings for fuel nozzles and screens. PCI is a privately owned small business located in North Haven, Connecticut. Our skilled technology and product development team is focused on developing solutions using coatings, catalytic reactors, sorbent modules, and systems for use in energy sector applications. We have multiple innovations under development which utilize our leading-edge coating technologies, including fuel reformers, fuel processors, fuel cell power generation, gas turbines and jet engines, tactical power generation using internal combustion engines, fuel filtering, and air revitalization. PCI has been successful in our field, working with a variety of DoD and other federal customers, large and small business partners, and various national laboratories and universities. We have an experienced, capable team, including 14 PhDs that have developed leading-edge coating technologies, reactors, and systems. The company is experienced in government contract management and utilizing our contract vehicles to add additional funds for specific technology maturation tasks. Our project is focused on meeting the Navy challenge to prevent dysfunction of critical aircraft fuel system components due to carbonaceous deposition in fuel passages. In particular, developing a frangible coating for fuel system components, as blockage of these system component passages can have serious consequences in terms of aircraft propulsion control. The frangible coating will prevent carbon deposits formed from high temperature exposed fuel from blocking last chance screens and fuel injectors, which are exposed to the highest time at temperature exposures sufficient for coke formation. The coating is multi-layered and will release the top layer once carbonaceous deposits form. The released layer and coke particles are small enough so that they will easily pass into the combustion chamber. Fuel deposit issues currently prevent long-term fuel system operation at temperatures over 300 Fahrenheit. Our transition target is jet engines for Navy aircraft and missiles. Other transition targets include other high-temperature engines, shipboard and stationary power generation gas turbines, and commercial aircraft engines. Navy has an operational need to prevent fuel coking deposits from harming fuel system components and the aircraft engine from malfunctioning, and reducing maintenance costs, targeting a 5x increase in mean time between overhaul compared to the baseline at 400 Fahrenheit fuel operation. A frangible coating that can slough off carbonaceous deposit precursors, adhering and growing onto fuel-wetted surfaces, such as last chance screens, to prevent dysfunction of critical aircraft fuel system components, has the potential to help the Navy meet their operational need. The frangible coating can be utilized on all engine platforms with a focus on higher operating temperature engines, as well as helicopter engines, ship service turbines, and commercial aircraft. Our frangible coating will slough off carbon deposits adhering and growing onto fuel-wetted surfaces, thus preventing blockage on the most critical, most susceptible aircraft fuel system components, resulting in improved, more consistent performance and lower life cycle and maintenance cost. Initial development will focus on technology maturation for Navy jet engines, but the technology can be extended to other high-temperature engines and stationary power gas turbines. Target specifications of our coatings include frangibility. Low cohesive strength of nanolayers prevents buildup by shedding adhered varnish precursors. Nanoscale conformal coating for complex geometries applied via vapor deposition. Lubricity equal to or higher than underlying material. Coefficient of friction equal to or lower than underlying material. And chemical inertness. Temperature stability up to 600 degrees Fahrenheit. Nano to micrometer coating thickness. And no off-gassing or other contamination. The thickness of the coating and its erosion rate should be adjusted such that it can remain operational for a time frame comparable to a typical fighter aircraft engine service interval, targeting a 5 times increase in mean time between overhaul compared to the baseline at 400 degree Fahrenheit fuel operation. We have developed an initial coating approach with individual components being validated under conditions of temperature, pressure, and fuel flow velocity typical of aircraft engines. We're having ongoing interactions on the technology with interested manufacturers. And we're focused on doing our development and completing our milestones, targeting completion of testing of coated components and delivery of TRL-5 frangible coated last chance screens by January of 2025. Key features, attributes, and benefits are shown. The technology offers to reduce maintenance cost and maintenance burden on sailors and Marines, extending the maintenance and overhaul interval for last chance filters by at least a factor of 5. Be cost-effective in material and processing, and vibration and heat tolerant, but easily shuttable to remove carbon deposits. Transition to the fleet. We need to integrate with an aircraft jet engine, conduct integrated ground tests, flight qualify the coated components in the aircraft, and transition to the fleet in a multi-million-dollar effort over the next several years. To help us with the transition to the fleet, we are seeking multiple partners such as ONR, NavAir, and other interested DoD customers, prime contractors, fuel system component manufacturers, and synergistic venture investors, those investors who bring adjacent technology or an application with funding. Thank you for your time and attention. I invite you to chat with me at our booth during Navy Sea Air Space, or email me to schedule a meeting. Thank you again, and enjoy the rest of Sea, Air, and Space.